Hi there, physics students. This is a little tutorial on how to make a graph specifically using a Macintosh computer. We're going to be using Excel, and so if you have a PC or if you have a Mac, it's really going to be basically the same. It's more difficult on a Mac, and more students in our classes have Macs, so I'm going to give you the tutorial here. But on the PC, you follow along the same ways. It's just a little bit easier. Okay, so this is the end result. This is what we want. We have some made up data, x, which I represent with the variable a, bleeps, which is b, and cezels, which is c, and then down here in parentheses are their imaginary units. Okay, and let's say that we've collected some data on whatever this is, and we're going to make a graph of cezels and x. Okay, and the cezels is along the y-axis, and the x are along the x-axis. And we can see here we get some relationship. We get a trend line. We're going to plot the graph. We have a title. We have axis titles, and then down here we're going to do a little analysis with the slope and the y-intercept. All right. So let me show you how that's done. We're going to just show you the raw data now. So here's the raw data, and now let's put in the graph. All right. So here's how to do it. I want you to click away from the data. A lot of you, I know, are going to want to highlight the graph or highlight the data and then press the graph, and then poof, magic happens. Magic is not great in science, okay? So in science, we want to be the ones in control. We want to say what it is we're graphing. And so this is, I think, the best way to do it. It's up to you. Different teachers do it different ways, but this is how I want my students to do it. Okay, so we're going to click away. Up here, we're going to click on the Insert tab. And then we're going to choose scatter graph. We're not going to connect the dots. We're not going to connect them with lines. We're always going to, almost always, going to do a scatter graph in this classroom. All right? And if the graph pops up over your data that you can't see all the data, you need to move it out of the way. Now what I want to do is I'm going to select the data. I'm on the chart design. So if you click off, you can always click back on again, and you'll see chart design and then select data. You want to add a series here. Ignore these boxes over here. You want to add a series. There's the series. We can give it a name if we wanted to, but because we're only going to graph one series, then we don't really need to name this. Okay, so now we choose the x values, and that's going to be the horizontal axis. And if you remember, that was ACKS, A-C-K-S, this data over here. So what we're going to do is we're going to press this little button, which is going to minimize this window. Okay, and it's going to allow us to highlight numbers on the x-axis. This is just the data. You with me? Okay. We're not highlighting the header information, just the numbers. I take the button, I blow it back up again, and there's my raw data for the x-axis. For the y, I'm going to do the same thing. I recommend that you press this button to shrink it, and then you can highlight the values along the vertical or the y-axis, and this would be the cezels. So I've done that. And when you're done, you can press OK. And now we have a nice graph which shows the cezels here and the x here. Of course, you're going to forget what's being graphed along the x and the y-axis, so it's really important that we add those titles, the axis titles at this moment. So if you have a PC, there's a little plus sitting out over here. You press the plus and then you choose axis titles. For those with a Mac, it's a little bit more complex. Click on the chart and then come over here to add chart element. And we choose axis titles. We want the primary one, the horizontal primary. And we want to click it again and do axis titles primary vertical. The data table should have a name, each column should have a name, should have a variable, it should have a unit. The same goes for the axis titles. So the axis title needs to have a name. Again, this is the vertical, so that's cezels. See, and this is a text box, so I could just hit enter to go to the next line and add centimeters, or not centimeters, but CZs rather, whatever that unit means. Okay. Next, I click on this guy here. This is my triple click to highlight all the words, and then X, the variable A, and the unit here is AK, again, something made up. Students often ask what should go on the chart title. I think this is a pretty straightforward way to do it. I like to do the y-axis, Sezzles versus what's on the x-axis, and then of some object, of a ball rolling down an inclined plane or whatever. So, of a, quack falling on Zork or whatever. This is all just a made-up thing, right? So, y-axis versus x-axis of some phenomenon. So now that we have the title done, take a look at this. If you click on the chart, you'll see that the data is actually highlighted here on the data table. The data that you're graphing is highlighted on the table in these little pink and blue boxes. And that tells us what data is actually being graphed. So that's a good little check to make sure we're actually graphing what we think we're graphing. If we wanted to, we could grab these corner pieces. Let's say we didn't want the first 3 data points for whatever reason. They were maybe bad, or maybe they were taken, you did those incorrectly. There's got to be some scientific reason that you get rid of your data. So let's say that there is, you can get rid of it by simply not showing it on the data table, or not showing it on the graph rather. The other thing you can do is if you grab the edge, not the corners, but the edge of these boxes, you can move them around. And so, for example, if I wanted to graph axe versus bleeps, I could just move that box, let it go, and there it is. I can quickly change what I'm graphing. Of course, I would have to change the axis titles for that. But here we go, back to here. Okay. So we can see that we could qualitatively look at this. We can see that the trend is kind of linear, that it is increasing with X, that sezzles get bigger and bigger and bigger with X, at least for the data that we have here. But we can't really tell a whole lot else about it. We can see that it crosses the x-axis around 5x. We can't really tell exactly where it's going to hit the y-axis. We can't really see the y-intercept. We can maybe interpolate and go, I don't know, it looks like 25 or so, negative 25. But we don't really know. We're doing qualitative analysis, and we want to do quantitative analysis with numbers because, we're in the science class. So let's do that by adding a trend line to the data. And the data itself is beautiful, right? It's a beautiful little picture, and it tells us something by looking at it, but we need to really think about the quantitative, the numerical analysis. And so we're going to click on chart design, click on chart and chart design if you're not there. We're going to add a chart element, and we want to add a trend line. Okay, don't just click linear. I know it's linear, I can see it's linear, but I want to add more trend line options. Okay, so click that. On a PC, you're not going to see this window. You're going to see the window that you're supposed to see. On a Mac, you have to actually click trend line options again. So click on that little tab and it opens here. On a PC, you'll actually see this window. Here you can change what's being graphed, if it's polynomial or logarithmic or linear or whatever. And so it looks pretty linear to me, so let's try linear. And the other thing you want to do is display the equation onto the chart. There's the equation, the relationship, the numerical relationship between sezzles and x. And we also want to display this thing called the r-squared value. Okay, so the r-squared value, well, let me first of all make it bigger so you can see it. This is just a text box here. So I can go to home and I can increase the size of the text box. Okay, and this gives us the relationship between what's on the y-axis to what's on the x-axis. Let me say a quick word, very quick word about this r-squared value. R-squared values is a statistical analysis that tells you how good your trend line is to the data. An r-squared value of 1 means that your data is exactly, the trend line exactly agrees with the data. So this data is 100% linear. If I were to change a data point, say make this 4.44 or something like that, and hit enter, my data would change, my data point would no longer be collinear, and my r-squared value would not be exactly 1. Okay, it would be very close to 1. We would be happy with this data. It looks pretty good. The trend line seems to match the data pretty well, and it seems to be linear, but it's not exactly that. So in our class, we hope to get numbers that are kind of like this, 0.99 something. If you get 1, that means you're either really good, or you're probably cheating a little bit, or maybe you're fudging your data. So we want to get close to 1. The y value here is Cecil's, so we want to change that. We want to see what, gosh, we want to see that this is not y, but rather c, because that's along the y-axis, and then along the x-axis is our a. So this gives us the relationship, the mathematical relationship between Cecil's and x. And I can then type in 20x, which is not even on our graph, and we can predict what the Cecil's would be if we wanted to know that information. All right, so that is pretty much it as far as the graph is concerned. It is kind of nice though to have some analysis. Before I quit this, I just want to show you how the next step of the analysis is going to be. So because we have lots of different data that we could be graphing here, Cecil's maybe versus x. Okay, I want to type slope here, and I want to also figure out what the y-intercept is here. Okay, and I'm going to right align these because I want my data to go here, make a little border. The slope of this is this number here, 5.2. Okay, and I could just type 5.2 if I wanted to, but really there's a nice equation here. It's the slope equation. So you type equals slope, parentheses, and then it gives you a little hint. Highlight your known y values. Well, what's along the y-axis? Oh, Cecil's are along the y-axis. So I'm going to highlight those. And the next thing, if you look really carefully, is a little comma. And then you're going to highlight your known x's. That's the x. Hit enter. Now, 5.2 should agree with that. And if I change this value here, okay, notice that this number changes, but this number does not change. That's because you've altered the equation. You've turned it into a text box. It's no longer y versus x, but it's rather c and a. So this value will change, okay, but the equation on the data table does not. Okay, so undo is our friend. Control Z, Command Z. And then the next thing is the y-intercept. So that's equals to intercept, parentheses, known y's, once again, comma, known x's. Okay, because these are equations, I like to highlight them in yellow so that I know that they're an equation, maybe center them. Lastly, these are numbers, so they have to have units. The slope is rise over run, so this is CZ versus AC. And so now the unit for the y-intercept is CZ. Notice that it's trying to interpolate and think what we want to type in, and maybe the same thing we just typed in, so you have to press delete or press the space bar to get rid of that /AK. It's only CZ. Again, the y-intercept is where the trend line here will intercept the y-axis, and that number here is going to be around maybe 25 or so. We can see here the statistical analysis tells us it's negative 26.1, but what are those units? 26.1 watts. Oh, it's got to be CZ, so that's on that. That's what the unit is here for the y-intercept. For the slope, it's rise over run, and so rise CZ's over run divided by AK. CZ's divided by AK. So before we put this lab to bed, we really need to consider the precision and the uncertainty of our measurements. So if we look here, we see that we can report the slope to 2 sig figs, and we can report the y-intercept to 3 sig figs, and that may seem perfectly doable. Actually, you know, the computer, that's what it gives us, so why don't we believe it? How precise we can report our data is really dependent on how precisely we measured our data. Alrighty, and so these are just numbers I made up. I actually typed in just 1, 2, 3, 4, 5, 6. Obviously, I didn't do any measurements. But let's say I did. Let's say I actually did, and I can only get this right to 1 sig fig. This one has 1 sig fig. This has 3 sig figs. This one has 1. This only has 1. Okay, so our data is littered with one significant figure throughout. If that's the case, if that truly is what we measured, okay, and maybe it's not because we were bad, but maybe it was because the instruments weren't great or the conditions weren't great, and so we're limited to one sig fig. Regardless, we have one sig fig here, and so therefore we can only have one sig fig here. So we need to decrease the decimal, for example. I can only have one sig fig in the y-intercept as well. I could decrease that decimal, but that still leaves me with 26. That's two sig figs, and I need it to be 1. So here we have to just simply type in, change that y-intercept. Okay. All right. Let's pretend, though, that I actually measured it to a much more, measured it much more precisely. Maybe something like this. How about that? Yeah. Okay. So it's a 1.00, right? And that's 100 times more precise as just 1. So here, sig figs, when you collect data, make a big difference, and they really matter in the laboratory. So here is 3 sig figs, here's 4 sig figs, here's 3 sig figs, this is 2 sig figs. So it looks like if we look at the data, yeah, it looks like this number right there is our weakest link, and so we're limited to 2 significant figures in our data, 2 sig figs in our data. So what that means is that we can live with this. The 5.2 is okay because that's 2 sig figs, but we can't live with this. We need to decrease the y-intercept down to that. And so that's how we would report this data if we were to measure as precisely as possible. I hate it, but that's the way it works in the big world of science. And that's also why sig figs are really important. All right, hope you learned something. This is what you're going to do for almost every single lab that we do this year. So make sure you understand this. Use this as a little tutorial. Take notes on it if you want to. But this is what we're doing every time. To recap, we're taking our data table. We're graphing something in our data table. We're graphing something along the y-axis, something along the x-axis. The chart title is y-axis versus x-axis of some phenomenon. We're going to plot a trend line to that data. We're going to take the trend line and add the equation of that trend line to our graph. We're going to plot the r-squared value, all right? And then in our analysis, and we can kind of clean up the analysis here a little bit, make it look nice. The analysis is also going to be done almost every single time we're going to record what the slope of the graph is. We're going to record what the y-intercept of the graph is. Numbers with units with the correct number of sig figs. The slope of the y-intercept, you don't realize it now, but the slope of the y-intercept is going to tell you a lot of things about the physical world. And that's why we're always going to report the slopes and the y-intercepts of almost always, of our graphs, okay, with units. If you have any questions about this, please contact me, come see me, and let me know how you do. I hope this was fun for you. I really enjoy this. I think it's great. It's my artistic release for as a scientist. All right, y'all take care. See you. Bye.